All right, students, I know I lied to you. I said that last video was going to be the last video, but it started to get long and I didn't want to make it overwhelming, so we split it into two. So here we go. Oxidation reduction reactions. Redox reactions, remember, are the transfer of electrons. We're moving electrons, they're moving around. So there have to be two parts to it, because if somebody's losing electrons, something has to gain electrons, right? So if we look at that, we have oxidation, all right? Oxidation is losing electrons, so you lose electrons, all right? The little mnemonic device that I remember is Leo says grr. That would be down here, all right? So reduction is then gaining electrons, because if someone is losing, someone has to gain. And it's all based on their oxidation numbers or oxidation states, all right? For our purposes, we're going to say that these are interchangeable. In a higher level chemistry class, you would probably not say that, but for our purposes, we are. So let's talk about how to assign oxidation states or oxidation numbers. So oxidation number of an element in its elemental form is 0. So when an element is in its natural state, it is going to be 0. We know that because that's what it says on the periodic table. The oxidation number of a monatomic ion is equal to its charge. All right? That is also something we know. Now, the sum of oxidation numbers of a neutral molecule has to all add up to be 0. An ion then has to equal its charge. All right? So now a couple other rules, and then we kind of have to figure it out from there. So in group 1, metals are always positive. Group 1 is always +1. Group 2 is always +2. From there, it can kind of change. All right, our nonmetals, we know hydrogen is always +1. Always. All right, oxygen is -2 except in O2, where each oxygen is -1. That's peroxide. All right. Then we have to use the other elements around it to determine all of our other nonmetals. So let's take a look at that as we have some examples there. So we have Cl2 to start with, right? It is in its natural state. Chlorine in its natural state is a gas and it's Cl2, so it's 0. All right? Na+, well, we know Na is going to be +1. So now, as we're rolling along, we've got K. We know K is in group 1, so it is always +1. Then we have F. Since our neutral molecules have to add up to be the charge on the, or our neutral molecules have to add up to be 0, F in this case has to be -1, and F is usually -1. All right, so let's roll on. CO2. Now, you're like, is that peroxide? Peroxide only shows up with another metal, all right? C is a nonmetal, so right here we just have carbon dioxide, right? The name of this is carbon dioxide. We do not say peroxide there, all right? So C is the one we have to kind of figure out. If each O is -2, if each O is -2 and we have 2 of them, that gives us -4, so carbon has to be +4 in this case, all right? Let's take it a little step further here. This time we have SO4 2-. We know each O is -2. All right. But we also know, if we look at it like this, each O is -2, right? And we have 4 of them. Okay, I blow this up a little bit bigger so we can see it. We know our charge has to add up to be -2, and this is -8. So what does S have to be? It has to be +6. So S in this case is +6. And that's something you've probably never seen before in your chemistry life. Okay, let's roll on. Then our last one here actually brings peroxide, right? There's peroxide. Because each K is always +1. So our O in this case has to be, each O has to be -1. All right? Because it's with a metal, it's peroxide. All right? Awesome. So, taking a look and seeing if we can't apply our knowledge to figuring out which substance is being oxidized and which one is being reduced. So our first step is we go through and assign oxidation states or oxidation numbers to each of them. So magnesium in its natural state, 0. So we're going to leave that there. All right, hydrogen is +1, oxygen is -2, right? Keep on rolling. Over here, magnesium is with a compound. We have our O, which is -2. Our H is +1. Our magnesium then has to be +2. And then our hydrogen over here has to be 0 because it's in its natural state. So magnesium goes from 0 to +2. 0 to +2. Is that losing electrons or is that gaining electrons? It's becoming more positive, so it is losing electrons. So this one is oxidation. All right. Now, our hydrogen is going from +1 to 0, right? +1 to 0. So it is becoming more negative, which is our reduction. So we say this is being reduced or reduction. If I could spell reduction. All right, awesome. That's the end. See you next time.